Welcome, everyone, to the American Space Museum. I'm Mark Marquette. So glad you're with me to stay curious with Terry White beside me, and he's going to talk tiles like only a space worker of our wonderful shuttle era can talk about it. Terry, we got our gloves on for Tile Talk with Terry. How about that?
That works.
That works there. We're going to reprise real quickly the launch that Marty chose as our green screen behind us here last night. That was a pretty launch, and we're going to look at a door that was on the aft of the shuttle that we own several of these doors, and
Yes.
you guys have told us exactly what we have, and Marty took out a picture of where it belongs when what it's there for. So we're going to have a very interesting program with Terry White. Those of you that are new, Terry, tell them what your job was for NASA.
Okay, well, I was an orbiter processing chief, but I was basically responsible for getting the orbiters ready in the orbiter processing facility, doing or managing all of the work that we did from one flight to the next, taking apart what came back from the previous flight, doing all the testing and getting it ready for the next flight. And I was also had the title of the grandfather of TPS, in other words, the grandfather of tile. So,
And TPS is the acronym for
all of the insulation
thermal protection
the
system.
thermal
was what I wanted
protection
to get out
system,
there.
all
Yeah.
the insulation on the outside of the orbiter and some of it on the inside that have protected it from the extreme heat of launch all the way through its flight in space, and especially through the extreme temperature of re-entry.
Now that's something you don't all think about, the heat of launch.
Yes.
Because to explain that real quickly.
Well, basically the aft of the orbiter around the main engines is also covered with TPS, with tile and that. And when those engines
hold that for
and
you.
boosters ignite, the heat comes up. Even though it's funneled down to the flame trench, there's still a lot of heat back here. So these only see heat primarily on ascent. On re-entry, the heat is on the underside of the orbiter, so back there is relatively cool between the engines.
Coincidentally, I've got a slide that'll show you.
Yeah,
the base that heat.
Yeah, all the
So,
temperatures.
Terry's been on our show for a couple years, and we have had his whole family on here. And your son Travis is doing his fourth or fifth deployment overseas.
Fifth deployment, yes.
And is he okay with?
Yeah, he's okay. I talked to him today, just before I left the house. He's doing all right. He said he was going to try and watch the show, but it's 10 o'clock his time, so he may not stay up for much of it.
Well, but an important question for me is, when are you going to go back to Louisiana and get some more of your daughter Rebecca's gumbo?
I was just out in Louisiana last week, but they did not have gumbo this time. So.
I'll take jambalaya too, you know.
No, this time it was the oldest grandson's birthday, so they had hot dogs and beans and all the fixings with hot dogs. So.
Well, Rebecca's something else. Good family, and your wife and all the family members watching today. Bedelia onions you'll be leaving with from Gary Gerald and his farm up there in Collins, Georgia. Gary, I know you're watching today. Let me push the button here as I'm welcoming Marty Winkle. Marty, great to see you back in the saddle there, and Raj was in good form, pinch hitting for you there, but he's got other duties he's doing today. Tom Usiak and Tom Colbert. Colbert's in Ireland, and Tom Usiak, of course, in Pennsylvania. Tommy was hotter yesterday than we were here in Florida. Did you see where
I saw the
coast was like?
Yeah.
We were 91. I think you were at least 95 in Pennsylvania up there. I saw Pittsburgh was.
Yeah, their heat index was over 100 for a lot of places.
Yeah, and there's Gary Gerald on there, and Tom Celentano. Interesting topic as usual. Yeah, we're always going to learn. Like, Terry can probably tell you exactly where that came from on the orbiter, even though there's 30,000 tiles. And you look at it, you see a little bit of seam chiseled in there that fits into somewhere.
This one came off of the OMS pod. The orbiter maneuvering pod actually comes off, excuse me.
Yeah.
Yeah. It actually came off of the aft of the OMS pod back around the orbiter maneuvering engine. So it's one of the tiles that goes around there.
Interesting. It's a black tile.
High temperature, reusable surface insulation.
Okay. All right. Well, you all got questions for Terry, just chime in with them. I'm going to pop the image up there to remind y'all that Saturday is our auction, our 38th auction. Important to keep our cash flow going. This is a big part of that. Chuck Jeffrey has 350 lots of real good memorabilia. Over your head is uh, Neil Armstrong's X-rayed boots. That's a heat shield we're going to see up close, and a piece of STS-1 tile, and Buzz Aldrin's autograph. All things that should be in your collection and can be. And you can go look right now on the website. Let me boost that up there if you want to put that up there, hit your QR code or rewind and go back and check it out. Final gavel is starting at noon on Saturday, and I'll be watching and betting on a few things myself. So, you ever watch that?
Yes.
And your impression of it?
It's a great way to collect memorabilia. Yes.
Also, a good history lesson
Yes.
too. You realize what? I didn't know what that was, or there's actually in there something I learned was the device that cuts the parachute cables.
Oh, okay.
Those come up for sale. It looks like a stapler for better, where we have one on the shelf in there.
Yeah.
But a piece of STS-1, okay, of the shuttle program there. Cheryl Armstrong was a executive at Johnson Space Center. She
Okay.
was a executive secretary.
All right.
She was really the right-hand person to the JSC director. And there's a tile that you can buy.
Yeah, that's off
BO10.
BO70. That's a wing tile. A 191021 is the assembly.
Well, I knew you'd know.
Yes.
And I don't know for sure, but there are some rules about owning shuttle tiles. You know anything about that?
No, in the beginning they weren't allowed to sell them, but there were some that NASA agreed could be sold by a guy that got them from Lockheed, and then more tiles have shown up. So I don't know the exact thing but now NASA has given tiles and blankets out to universities and to high school principals, and that they have to pay the shipping and that, but they have given them tiles, and I thought they were giving them the extra tiles we had, but it turns out people contacted me, and by the part number and the serial number, those were actually flown tiles they're getting. So
We do know we don't ship it to Europe. There's something about the makeup of the tile or something. We can't ship them to Europe, and be very cautious about any 51L or 107 tiles.
yeah, that's strange.
That's has become evidence.
yeah, that's strange because I used to have a kit that employees could take around to schools when they were doing their talks that had the tile and that, and they could explain things to students. And I wanted to send one overseas with our overseas landing people and that, so they could talk to the people in Spain and that about it. And NASA told me, no, you can't take them overseas. And I thought, that's odd, because you can actually buy a tile at the visitor center then. It wasn't a whole tile, it was one that was just made up for that. But I said, it's a little odd because anybody can walk in there and buy one and take it overseas.
Well, it's interesting. We have a lot of the raw material.
Yes.
I've shown you a few times.
Yes.
Just yeah, you better be wearing gloves when you're handling it there, and that's why we got gloves on today.
And Russia
on Stay
made
Curious.
tiles for their vehicle.
Yes, the Buren.
Yeah, it had tiles on it. So I don't know what the people overseas can get a tile.
Yeah, all right. I don't know. I don't know exactly what the deal is, but we just heard a launch out our windows like 5 minutes ago, and it wasn't this launch. This is the launch of Peggy Whitson, and these three rookies. We've got to change the board out there from 633 to 636. We'll show you that tomorrow. But there's the what a nice launch. I got these photos from SpaceX Facebook page and just shared them off of that. So Carlton Bailey, if you know who the photographer is, let's give him a shout out. CB says that 4 rocket launches in 3 days now.
Yes.
As we saw Starlink go up in there. But look at that beautiful ponding there, the water. That's one of the best. That's the best I've seen
Night
in a long
launches,
time.
night
That is.
launches are impressive.
I want to know who that. If that's Ben Cooper. That kind of looks like maybe his work. Carlton Bailey. If you can help me there, let me know. But great. That's Carlton's shot that he sent me. He was out there losing sleep. Uh, Probably about midnight, Carlton, 11:30, when they went out to the pad to change their into their spacesuits. They didn't walk out traditionally like they do.
Okay.
And there's a close up of the launch. And what I watched through the binoculars, I've been waiting to see this when the first stage, second separated. This is the exhaust being created in a nebula fashion by there's both the second stage is at the bottom here. Let me do it this way. There's the second stage lit with the crew headed to orbit, and then there's the first stage coming back. It creates this exhaust. Note sometimes there's a tadpole effect, but this was like a nebula. Boy, photographer captured that beautifully. I saw it like that in binoculars. 2:30 in the morning, and sounds easy to take a nap, Marty, get up and watch it, but really getting back to sleep, that's the thing. I just couldn't get back to my deep sleep there, but great photography there. And Marty said it looks like the two guys shaved before the flight. Okay. Yeah, they may have there. Marty's got a question.
We actually have two questions. One from Heb Metz, and she, by the end of the program, were most of the tiles on the orbiters original to each of them from their maiden flights?
Yes, especially like Atlantis, 85% of the tile on the orbiter at the last flight were original tiles from Atlantis's first flight. Now, Columbia had a lot less on its last flight because we'd done a lot of modification and removed a bunch of tiles and replaced them with the flexible insulation blanket. So I don't know what percentage of Columbia's were still original tiles.
It's looking at Atlantis Saturday night. I'll show you some pictures of that tomorrow. What I was doing over the weekend. The black ones are the new ones, and when you see that so few black ones, you're going, "Wow, Atlantis just
Yeah,
85,
all those
90%.
gray ones were originally black, but they got grayer and grayer with each flight. But yes,
Yeah, and you see the streak marks always. Ped Metz says always enjoy seeing Terry when he's on. Okay, Peggy was on there saying hi to you, Holbert. Your sister Patty is probably watching.
yeah.
Or if she's not washing your dogs or something for you. Hi, Patty. And Carlton Bailey, don't know that photographer, CB. He's saying hi, as is Steve Jokums, to all of his friends here at this social gathering we call Stay Curious. Marty Winkle, go ahead, buddy.
Okay, we have a question from Gary Gerald. Terry, can you discuss the boundary layer on the bottom of the orbiter and how it affected the heating of the tiles?
It's probably a little easier with a smaller one than the big model, but as the orbiter's coming back in, it's pushing a layer out in front of the orbiter, and that's keeping the maximum heating away from the tiles and from the orbiter. And they call that the boundary layer. And we don't want to trip the boundary layer as it's coming back in, because then it will start heating the orbiter earlier or heating it higher than it should be. And I tell people it's like you're baking a batch of cookies. If the recipe calls them to go in the oven for 12 minutes and you leave them in the oven for 20 minutes, you're going to get burnt cookies. So that's the same way with the orbiters. It's coming back in. If we trip that boundary layer, it starts heating sooner than it should. So we're going to heat it longer, which potentially could overheat it. Plus, we're going to get higher temperatures. So it's really important that we don't trip that flow of air that is pushing across there. And that's what the protruding gap fillers did on return to flight on Discovery. They were worried about those gap fillers tripping that boundary layer and causing overtemps back on the elevons and the trailing edge of the wing.
Excellent explanation there. Uh, and we're going to hear more about that. But Google Terry White's name in the search engine of our over 1,000 episodes on YouTube. And you're going to learn a whole lot about a lot of stuff and see us having a lot of fun about it here. And Terry's bringing new people to the museum, some of you shuttle workers in the area. We'd love to have you part of our family here. We need docents, we need people to show up. And we've created Shuttle Fest just for you all. And you've been a big part of that, Terry, and we appreciate you there. Carlton Bailey thinks Ben Cooper took these photos here. He's an awesome photographer. And we've got Tom Usiak says it's 95 in Pennsylvania, hotter there than here in Florida. You don't have our humidity though. It's not too bad. And,
Yeah, but they don't have our ocean breeze either.
And Marty, Tom, do you see his question there?
No.
Terry?
I see it now.
Yeah, go ahead.
Okay, Terry, were you at the pad when the tiles were cleaned and replaced for STS2? And were any tiles damaged where they had to be replaced?
You're talking about the oxidizer spill on Columbia on STS2, and we had to remove 380 some tiles from the orbiter out at the launch pad. And the oxidizer didn't hurt the tiles, but it turned the paint on the structure back to a liquid. So the tiles were coming off of the orbiter. And luckily we did not drop any, but I spent the first night after the spill up there with my arms on the orbiter holding the tiles on because they were all trying to slide down and come off. Myself and 2 technicians stayed up there all the way through second shift, which was our shift. Third shift came on and they didn't have anybody certified for hardline breathing because we had to have breathing air on out there. And so we stayed up there for third shift, and then first shift came in the morning and they had a special training class set up for some of the people that were certified to handle the tiles and that to get them hardline breathing certified, and finally got relieved at 10 o'clock the next morning to come down off of the pad. So, but we did not drop a single one. We had to take all of them off. We had people there with special bags to put them in, and then we had to heat clean them. And we messed up all of KSC's, Kennedy Space Center's ovens, heat cleaning them, and then we sent them out to Patrick Air Force Base and their ovens out there to clean them up and that. But we did reinstall all of the tiles back on there. I don't recall having to replace any of them because of damage, but it was a tremendous effort out at the launch pad. And they actually built me an office, me and my counterparts on first and third shift at the launch pad, and set up air conditioning that in a crane room at the 207-foot level at the pad so that we could stay out there around the thing. And they expected us to take a couple of months, and I think it was right at 3 weeks when I came down off the stack and I said, the last tile has been installed. You guys can return to your count.
Awesome. And which orbiter was that?
That was Columbia, STS-2.
Oh, that was on 2.
Yes.
Okay. In November 1981 is when that was launched. Yes, Marty.
RG Jubilee is asking, when the Columbia was returning home, what part of Columbia did the flames go into a tile fall off? And how did that explosion happen?
When Columbia was coming back, I don't believe there was an actual explosion. Columbia was just literally torn apart as it was coming back
show
in.
them where on
at the speed, yeah. But it had melted the wing, the left wing, from the inside out, and we found very little of the left-hand ohms pods, none of the left-hand upper wing, and that all of that stuff was disintegrated as coming back in. But ultimately what happened was the orbiter was coming back in, creating so much drag on the left wing that it turned the orbiter sideways, and at those speeds it was still flying. It's not designed to fly sideways, so it literally just tore it apart. And it still saw some temperatures that we didn't expect because we were picking up tiles out in the woods and the cow pastures and that had literally melted and then re-solidified with icicles of silica on the tiles.
Thanks for the question there. I see joining us is Alexandra Manderbeck from Rio de Janeiro, Brazil. She's got a question that's a good one to Terry White here, the grandpa of tiles.
Okay.
Okay. Grandpa, here's one for you. Did any of the astronauts receive a tile from a mission they flew? Did they remove a tile and give it to any astronauts?
I'm not aware that they received a tile from a mission they flew, but there were astronauts that received tiles. I actually gave tiles to certain astronauts, but I had to get permission from the program manager in Houston to give a particular astronaut a tile, but I never traced that tile to one of their specific missions. I tried at the end of the program to get tiles for all of the astronauts that wanted a tile, and NASA Houston never cooperated with issuing out those tiles, because we had 19,000 surplus tiles left in the VAB at the end of the program.
Wow. And
So
each
some of-
orbiter had over 30,000
Yeah,
times
well,
5.
Over 24,000, yeah.
24,
But but some of them were actually Challenger because of an issue we had with Challenger before its actual final mission, is we had to remove a bunch of tile off of it, so we put brand new tile on in lieu of the ones we took off, but the ones we took off were still capable of being reinstalled at some time in the future, so we just put them in the spares category.
Excellent, excellent. Marty, read Tom Celentano's comments there. They're good ones.
And Tom is saying,
And I'm going to walk over to
incredible
the.
dedication from the workers.
No, wait there. Sir.
I hope you got overtime for working beyond your shift.
Since I was a supervisor or a manager, nope. Did
No?
not get no overtime.
I was going to ask you. I
And,
thought,
and then when they finally did approve it, you didn't get time and a half and never double time, but you did get a little more than your hourly rate. And at one time, that's why they changed the job title to Orbiter Processing Chief, because then we could get paid for more hours. So
excellent, Tom. Great question, Marty from Peb Metz.
Were the thermal blankets more or less difficult to work with than the tiles?
the thermal blankets covered a lot more acreage. In other words, the largest white tile was 8 inches by 8 inches. The thermal blankets were 30 by 30. So we covered a lot more area with a single bond, and they actually sustained less damage from one flight to the next. So they did cut down on our turnaround maintenance and that. So they were good. That's why we tested them on Challenger, and then Discovery was built with the blankets on it, and then we even retrofitted Columbia with the blankets. So it was a time savings for us.
Excellent. Well, we're going to go off the tile here for a minute and come back to it. And we're going to walk over here. Marty was out. I was out at the Space Center one day, and we've got an artifact in the museum. And I was told what it was. So when I was out and saw Atlantis Saturday night at the One Space Party, I looked up where this was. Marty went out and took a picture today for me. Excellent job, Marty. And so I'm going to walk over here with Terry, and Marty's got an arrow, and he's going to point to the object. I'm going to go like, yeah, we're going to be small like that while you point out the object there, Marty. Actually, we're off camera, and that's good. With the arrow, point out, yes, this panel there, Terry, and I'll get the microphone over here more for us.
Yep.
This panel, explain what that panel is.
Okay, well, that up there you're looking at, that's the Flight 50-1 door. So that's the door that we go through to get access into the aft compartment of the orbiter to work disconnecting the engines and all the other work, the APUs and everything else that we have to do inside the orbiter. Okay, there's a 50-1 and a 50-2 door, the 2's on the other side. Okay,
But we have 4 of them.
okay. But this
All right, now I'm gonna have Marty change that, and I'm gonna go here and put them on the box of Adelia onions there.
do we need to set it up on the chair?
Now here I'm going backwards here like this. We possibly could.
No, we
Let me,
ain't got-
let me.
gotta
Oh,
change
here
the
I'm trying to
cam-
make it there. That's what I'm trying to.
So
do.
we don't have to change the camera.
Yeah.
Let's just set it up on the chair.
Okay. 1, 2, 3. It weighs about 35, 40 pounds, I'd say. All right, there we go.
Okay. This is the
Marty, zoom out a little bit.
Yeah.
Please, sir.
this is the GSE door, which stands for ground support equipment. So this is the door we put on to cover the access to the aft. We only put the flight door on when it's time to go fly in that, but we have to put this on and that, like when we leave the orbiter processing facility going to the VAB, we have to cover up that opening. So this is nothing but a plexiglass, excuse me, reinforced with aluminum door that goes on around, and we can actually, when it's installed, it's actually got a seal so we can pressurize for certain tests inside. But we put these on for when we're working on it on the ground instead of putting the flight door on.
I handle with care. Is it clear so you can make sure somebody's in there?
So you can make sure somebody's not in there.
Oh, not in there. Okay. Down to open. There's
Yep.
some leverage here.
Yeah.
It's got some very interesting hooks here,
Yeah,
clasps that go
yeah.
into something or something.
Yeah, these are the latches that help support it. So yeah.
And we're actually going to probably sell a couple of these because we've got 4 of them for some
Yeah.
reason.
Well-
What's that reason?
We had multiple orbiters.
Oh, of course you did. But it's just.
So we would have had
a rack and set.
8 of them.
Oh, each proprietary.
Yeah.
One size.
Well,
didn't
not
fit all.
necessarily proprietary, but yeah, depending on, there was times you may need to put all of these doors on.
Do you see
I
any
don't-
identification on here to tell us 2001 doors?
Yeah.
Or-
No, but you're reading it from the wrong
50.
side.
Yeah,
That's a
5001 door.
50-1 door.
Does it, anything of that gibberish tell me what?
Yeah, that's stands
what
for
orbiter it is?
G070. No, that's for ground support orbiter program, and then that's its actual part number, and that's its serial number.
Awesome, fabulous, interesting to know. No paper seals on door, lead seals only.
In other words, when we put this on,
Yeah.
and we put on any other temporary doors, we would put a paper seal. Not on this door. They didn't put it on for security to seal it. They would put a lead seal on instead of the
And
sticky
how thick
paper.
was that seal?
So, well, it's just a wire
Oh,
with a lead
okay.
that they crimp, so they know if it's been opened.
Real artifact, not flown, of course. Part of now this had been at the pad, and also
So
the
you would
OPF?
use it at the pad if we were clearing the orbiter, like we had an orbiter out there and weather conditions and that, we could put this on. Okay. We don't want to be putting that big flight door on because you could potentially damage the door, and it took a lot more fasteners to hold it on. If you look close up of all the holes that's around that door.
Yeah, point that out again, Marty. That's a good shot with the, please, sir, with the arrow there. This is what we're talking about.
Yep.
And that's all the connectors, right? On the pad would be on the right-hand side. What do you call
And
that?
and the OPF. Yeah.
Okay.
That's a T0 umbilical.
This is the left side, and then on the other side, this is the is another door.
Yes. Yeah.
All right. We have the one from the other side because as I looked at it, it's a square, but it's a little bit of a pentagram there.
Yeah.
See? I mean, not pentagram. It's a trapezoid, and pretty big. You know. Now you need a ladder to get off the wing to get up there.
No,
though.
we put a platform that goes right out to knee level.
Okay.
Yeah, the GSE's out of the way. You don't see it there. But in the
Marty's
orbiter
got the arrow
processing
right on.
facility, there was a platform that went right out to it.
Okay.
We had platforms that went
Oh
out.
yeah.
out
We're,
to
we're
multiple-
restoring our OPF, so if you've got a level
Yeah.
of each in there, I
Yeah.
got it now. Okay, this is so fascinating to learn about all this stuff. There's another angle of it, Marty. Good shot, my friend. Excellent shot. When I photographed it Saturday night, it was under disco light, and it didn't look right.
We didn't have those in the OPF.
Because this is something you're not going to get anywhere on the internet, on YouTube, whatever. You know, a real space worker, important figure in the workers' side, as well as management. Terry White talking about this door being part, maybe up there on Atlantis when it was out at the pad. As people were going in doing what? I'm going to show you pictures next of what that might look like. So
We'll
Terry,
set
let's
this
set
down.
that down. All righty. Very good. That's 50 pounds or
Yeah, just laying it back.
yeah, leave it back there. And I'll put it back in our workers gallery. A new item that we put on display. And new improvement things are going on like that here at the American Space Museum. So if you're local, come on by and check us out. And those of you that aren't local, we're going to keep showing you galleries from time to time.
Yeah. And now what we're just looking at, what's on the photo right there, is that's the doors. That one was a ground support door. We used it on the ground. But on the orbiter itself, people don't realize that there's over 600 doors and panels that come on and off of the orbiter
600.
as part of its processing. And we don't want to debond the tile or the blankets to get access. So we build the doors and install the tiles and the blankets right on the doors, and then we can take the fasteners out and take the door off. In the case of a blanket, here's a blanket, and you can see 4 penetrations right there, and that accesses four holes in the back of the panel. But basically what you do is you put the panel on, put your mechanical fastener, your bolt into, and that's what holds it on, and the blanket does not have to come off.
What's that bolt look like? A metal bolt, a aluminum bolt?
No, it's a metal.
titanium?
It's a metal bolt. Most of them are stainless.
Okay.
Okay, and it depends where they're at on the ship.
Pretty big bolt though. Diameter's a quarter of an inch. And
Yeah, yep. So, and this, all of that
close.
thing to to put around the holes and all that is all sewn on by hand. Yeah, and we handle them with cotton gloves because the oils in your skin can cause over temps and damage to the vehicle. So, I brought Mark a pair of gloves to wear today. Now for the tile, where they go on a door, you can see this one has got 2 round inserts in it. Okay, so this one would have been glued on to a panel, again on the ohms pod and that, around by the orbiter maneuvering engine and that. So this whole panel went on, the bolt went in, and then we had a ceramic plug that gets installed in here, or a frizzy plug, depending on the temperature that area is going to see, to cover up and protect the fastener. Now, some areas, the tile is relatively cool, and they don't need that ceramic insert, so they've just made a hole through the tile.
Hold that closer up there.
Yeah. Okay, a small hole, and you can see it right there, and that accesses that. Once the tile's glued on there, then that accesses the bolt to put it on. So when you're going out and doing your initial fit of the tile, you have to identify where that penetration hole needs to be, and the back shop actually machines the hole in there, be it a small one with no insert or a larger one with an insert, and then the back shop, thermal protection facility across the street from the orbiter processing facility, would go ahead and use ceramic cement and glue this one into the hole, and that way you had access to your bolt to take the panel on and off. So
Excellent, Terry. Details that I don't care how many times he's talked about this. You always pick up something new,
Yeah.
and also reinforcing, this technology, come from last century. How's it translated now?
Yeah, well, one thing about it is the panel or the door may only have 1 tile or 1 blanket on it. Some of them had as many as 50 tiles. The engine dome heat shields had about 50 tiles on a panel.
Okay.
So,
All right. How's all this translate to today's spaceships?
well, today's spaceships
little-
are still using the tile, and I haven't been out there to see any of them lately, to see Orion and that, and I haven't been able to visit SpaceX's facility to see, but for access, they still have to do the same type of work of creating a hole through the tile, and then that way they can take off the panels.
And like I said, you can hear Terry Moore talk about the evolution of the tiles as they learn things about them from the orbiters, including making them water resistant. We're not going to talk about that right now. If we have a little time at the end, we will, because I wanted to take you into the bowels of what was on the other side of that door that we were just showing you there. Not per se exactly that door. I got some random pictures, Terry, of what it looks like. A worker in there, you might even know who that is. But when you see the pipes, that's what impresses me. And then all these wires around the pipes, and then these these pop bottle rockets on the side of this thing, shaking it like a damn popcorn
Well,
maker.
that the fuel in the oxidizer line from the external tank is 17 inches in diameter. When it goes inside the aft, then it goes off and splits up to 3 sets of lines to feed each one of the 3 main engines. You have all of the other components that feed the engines. You have all the supports for the engines because these engines move hydraulically and that. And looking in here, you see the bright yellow is the padding where we're crawling around on our hands and knees. There are also yellow protective covers for this very thin tubing and that. The green and the pink are also protective covers, but there's an erector set of platforms that you have to install to get into the aft. You build it as you go forward and that, and then you have to protect as much of the fragile hardware as you can. And Mark's talking about the tubing and the wiring. I don't know how many miles of tubing is, but there's 200 miles of wiring inside the orbiter.
Wow. Now that ladder, because it's yellow, that means that goes out.
Yeah, anything yellow in there is ground support equipment, so it has to come out. Yeah, because when you go inside the aft, you still have to erect a set all the way up to the very base of the vertical, because that's where the auxiliary power units are, and you have to remove those by hand and lift them down out of the orbiter.
Look at those bundles of wires.
Yes.
Just, I mean, it looks like braided wiring of bundles there. And this was an issue on the launch of Chandra when the shaking, wires were rubbing against one of the nuts or something, screws, and short circuited out one of the engines. That I believe that also had something hit the outside of the bell.
Okay.
On one of them, and it was bleeding hydrogen. But I hope y'all are impressed with like a little claustrophobic maybe at times.
For some people, yes.
And also the lighting. Now this is looking where the circles, where the 2 bottom SSMEs are and the one on top. I love this picture.
Yeah, that's looking inside the after
look
the
at the
after the
piping up there.
engine's removed and that. Well, that's an engine coming out.
Okay.
Yeah. Okay, that engine's just being removed, and there's people inside there because you're on both sides of the engine. There's actually somebody riding on top of the engine as it comes out. And then Mark was talking about the lighting inside. The lighting all had to be explosion proof, so we had to have special lighting and everything. But these are all lights that we put in so that we can go in there and work and see what we're doing.
Very fascinating. Hey, I see both our daughters are on there. My daughter Jessie up there in Tennessee reminded you to like, share, subscribe, and maybe even brag about a little bit that you know who Terry White is. And we always say that guy with the handlebar mustache, and everybody knows who we mean, brother, there. So also Rebecca says hi, Grandpa, to you there in...
Give everybody a hug.
There you go, in Louisiana. Tom Colbert says, I always learn so much information, new information, every time Terry's on. Thank you so much. And that's what we're all about, is sharing things from the shuttle era that has changed our lives so much you don't understand how it's changed our lives. None more important so than 35 missions to build the International Space Station, where we could have just called it Space Station Freedom and not let anybody come, but the world cooperation is a great example. Could not be done without your team and others that worked, like Marty's team. Marty, my co-producer, worked on the engine side, and as a manager of the SSME computer systems, and it's amazing. And this is why our museum's growing, is because how we embrace the shuttle era. Terry and others are happy to tell their story.
And Marty tells me he always liked going in the 50-2 door. He doesn't recall going in the 50-1 door.
He didn't have to stoop down either.
Yes, he did.
Once you get inside, you can stand up.
Yeah, we like having short people for some tasks because we could lower them down into spots that other people couldn't get to.
Yeah, indeed. Well, that's good. Yes, I met some pretty tall astronauts like Rick Mastracchio that was in that Soyuz, and his knees had to be up where his eyeballs were when he got in that
Yeah,
thing.
I recall one time they were going to have to remove the forward reactionary control system module because of an issue. And we said, wait a minute, we can lower a tech down inside there. And they said, we don't think so. And we took a very small framed gentleman and held him by his ankles and lowered him down inside, holding him by hand. And he did the repair and we pulled him back out.
Really?
Yeah.
That's very interesting. What year was that, you think? In the
I don't
80s still?
recall. Yeah.
I'm
It was
saying you
early.
have to have a little more safety equipment than two hands on
Well,
the
he
guy's
wasn't
ankles.
he wasn't going to fall very far. We could just potentially damage the flight hardware.
That's
But
what
we're
they all
lowering him
say.
down inside a compartment, so we weren't worried about him falling. We were just worried about him doing any damage. So
Well, we've all learned a lot, and thank you for sharing your time with us. Let's look at a couple more. This is an interesting thermal protection system that you look at this picture here, and then this will make sense where this might come from.
okay, yeah, those are dome heat shield blankets. They're built by hand and that, but they go around the base of the engine. Remember, these engines move, so they can't have rigid insulation right up against them. So they have these special heat shield blankets up against them. And then the lady in the background is building more of the soft goods up there, more thermal barriers and that go to the openings and the things that maneuver on the outside of the orbiter and during flight.
That's part of your So Sisters group. None more famous than Jean Wright, who supported our museum, but there's about 16, 17 other ladies. I think one man that was doing that. And very interesting. I love looking at these when I'm looking at the engines of Atlantis.
Yeah.
I kind of just look at the
Yeah,
workmanship.
the
on
guy-
them
the
there.
guy-
Again,
the guy was-
reference, those would go on the other side where that person is pulling the engine out. Another gentleman on the bottom there. Yeah. You were saying, sir.
As well, the guy that worked there with all those ladies doing the sewing and that, he said he never got a word in.
I imagine. And he probably had to walk a football field to go to the bathroom. Go to the next building that had it in there. Maybe not. So let's reprise a little bit with Terry here. Appropriate time if you got any more questions for him, as we've enjoyed a good time with you as usual. Terry and I are trying to put some other programs together. One on the landing gear
Yes.
of the shuttle, and we'll maybe put that together for the next time that he's on. He's on usually once a month, and we certainly welcome him. Also, he's done a panel at our Shuttle Fest and supporting our Shuttle Fest with getting workers here to us too. But some of these workers we had here helping us got called back to work. So, and you know, once a lot of them go back as consultants, and it's pretty good money, I guess. Pat Atkins is one.
Pretty good money, and a lot of the next programs after Shuttle didn't want any of the Shuttle technicians. They said, nope, we're nothing close to Shuttle. We don't need your people in that. And a year later, they would call me and say, hey, we need this, we need that. I said, I told you, you need these people. They have the knowledge and the skill. I said, it may not be shaped like an orbiter, but still, it takes astronauts to space. It's got the same systems that the shuttle does, just in different configurations.
Well, what I always learn is that this is a thermal image of the shuttle coming over like New Mexico or something, and reentry, and the hotter places are your yellow and red. No, the hottest is the blue, I mean.
Yes.
The least is the red. And the purple at the tip is the hottest, where the edges
and the
are 6,000
leading edge of the wing,
degrees.
3,000.
3,000.
Yep.
Okay.
Yep.
That's half the sun's surface temperature is 6,000.
Yeah.
And
It's,
each tile is documented, is always something I learned, paperwork, everything.
and it's traceable.
What's the red tag there?
That means that there's a discrepancy against it.
Okay.
Okay, we would hang the red tape the red tag to the tile and that, and then the white is documenting the discrepancy, and then the engineer would put down the fix, or the certified technician would put down whatever was necessary to fix it. So
Mm-hmm. And when you look at an orbiter like this one in space, the black ones are the newest ones that were replaced.
yes,
right?
they've been replaced, so they're nice and pristine black, and the ones that are gray have been on since original build.
The ones that would bother me would be these right here that are on the close to the leading edge that you had to replace.
That looks like the
And-
lower S-band antenna. And to access the antenna, we had to take those tiles off.
Wow,
to-
is that it?
to-
Because I'm thinking, what kind of burn through caused it? Yeah,
Nope.
you forget about what's beneath there.
Yes.
Electronics and antennas, yes.
And those are not on a panel that you can remove.
you see the hatch right up there. So
Yep. So those are actually bonded right onto the antenna surface. Okay. And all the
how
antenna,
about this is a noticeable pattern? The two
all
off
the
your shoulder.
antennas are located on the lower surface. I mean, on the forward fuselage. Yeah. So you have more antennas down there. You have
Right there.
S-bands, you have UHF, you have
There.
TACANs, you have multiple antennas down there.
So those are replaced each mission?
No, but when we have a problem with the antenna, you
Oh.
have to take the tiles off
Yeah.
to access the antenna. And they're up top, and the only antenna that's not underneath the blankets or the tile is the KU band antenna, and it deploys out of the payload bay once they open the doors in space.
Yes, that's on the right hand side.
Right hand side, yes.
Which is starboard is the right.
Starboard is the right, and port is the left.
Port's the left. P
Easiest-
before S.
Now,
Yeah, left to
easiest
right.
way to remember it
I
is
couldn't-
port has 4 letters, left has 4 letters.
Okay.
That's the easiest way to
That's good,
remember
that
it.
is. So this is what I enjoy with Terry. I know I can just throw some slides up and maybe we'll just jumble some and say, what do you see? What can you tell me about what you see here? Oh, I'm sorry, that's a low resolution, but that's in the OPF.
It's in the
That's a
OPF. We're,
landing
we're
gear.
looking at the main landing gear door, and you can see the strut for the main
There.
landing gear. It looks like the tires are not on, but yeah, that's
So it'd be supported by other structures.
is supported by the jacks at the ET doors.
What's this orange?
That's where a tile's been removed. That's actually, you can see, yeah.
All right, so that's looking at the
Yeah, there's a tile has
body
been
itself.
removed right there. Yeah.
and the yellow to the left of it.
That looks like a tag of some sort. You can see in the center of the door, there's a tile removed because you see the green structure on the door,
Okay.
right by that
Yeah.
little walk-up stand.
Yeah.
Yeah.
Yeah, right
Yeah.
there.
Yeah.
You well, it didn't have a tag on it or anything.
No, it doesn't because the tile's removed. So you obviously know that it's
You
not
hope.
there.
You hope.
Nope.
So
We never took off with a missing tile.
and everything that flies has feathers.
Yes.
Is
In this case, these are called flipper doors. So what you can see on the right,
But also, you see what I mean by feathers, though.
yeah,
I
yeah,
thought you called them feathers.
flippers.
Oh, flippers.
Yeah. So to the right side is the elevon.
This is the edge of
Yeah.
the
Yeah, and to the left
port
side
wing.
is the trailing edge of the wing. So the elevon moves as it's up and down as it operates hydraulically, but you still have to protect that cove area.
Gets the model there. Just
So
I'll
yeah,
hold it
so
there.
the elevon back here moves, but you still have to protect that cove area. So if you flip it around the other side, the right hand side, you can see all those flipper doors, and they're attached at the leading edge of the flipper door, but not at the back. So as that elevon moves, that flipper door rides up and down on that door, on that trailing edge of the wing, leading edge of the elevon as it moves.
So if you're a modeler, to be accurate, you've got to have those lines in your artwork.
Yeah, those are all
or model or whatever. Then this part here is what we're seeing, and it looks like a rubber mat, but that is
Yeah, and we could physically walk on
What
the
the- you know,
wings and walk on the elevon.
what is that material? The black material.
And I forget what it is, what the actual.
It's not Inconel, is it?
No, but because it's on the upper wing, so that area sees less than 700 degrees,
Okay.
so it doesn't get hot up there. But you still have to protect it, and it's labeled no step because the flipper doors are extremely fragile. So you can walk on the wings with special covers on your feet, and you can walk on the elevon in the upper level position, but you cannot walk on the flipper doors. So you have to be extremely careful.
Exactly. All right. Well, we're glad that all of you are enjoying this today. Steve Jokum says, after following and reading about the shuttle for so many years, I always find out things I didn't know when Terry comes on. Thank you. And with about 3 exclamation marks there. And you met Steve at the
Yeah,
Shuttle Fest. And like so many of you, become family to us, bonding through these stories and our daily events here at the American Space Museum. And Mitch Rothman's one of those there. And
And just to make you feel a little bit better, this is the forward reactionary control system. That area right up there forward of the crew module and that. So we weren't lowering the guy a long way down. We're just putting him through an
okay.
opening.
All right, that sounds good to me. Yeah. All right. Yeah. Yeah. We're gonna pick another area of the shuttle and talk about and appreciate y'all watching. And like I said, the shuttle era created the International Space Station. Peggy Whitson and 3 rookies are going to dock. I wrote it down. 6 in the morning tomorrow, 7 in the morning, something like that. Huh?
I think it's 7.
Marty says close to 7 o'clock in the morning there. And let's see here. Let's see why don't you say hi, since Marty's got a record number of viewers, eyeballs here today. So
My wife's viewing today, and like we already said, my daughter and my sister and my son all viewing today. So and my sister Lori should be watching, but she has not been successful at connecting, but her and her husband watch every show that they can. So
you can go back and see the rerun anytime you want on YouTube, and just Google Terry's name, and over 1,000 episodes up there. We've got here, start there and say hi to there,
Tom Usiak, Tom Colbert.
He's in Ireland too.
Yeah, Dean Babcock, Gary Gerald, Tom
Celentano
was
here a couple weeks ago.
Carlton Bailey, say Elena.
Adhakara.
Okay, Jesse Q.
That's my daughter.
Mitch Rothman, and like I said, Rebecca, Doug Forrest, Firedo, Osaka Joe.
Okay.
I'll remember the Osaka Joe. So, and the Dudley Git Show.
Well, my best friend was named Dudley, and I know that's not him. But
Yeah.
thank you very much,
Yeah.
y'all, for watching. You got Marvel Luca Empire 33's become a regular viewer of us, joining our little family here. Patricia White, your wife there. Alexander Manderbach, he's in Rio. Cliff Watson is in Australia, Pomona. Freezing because it's summertime down in Australia now.
It's
down
wintertime in Australia.
I mean, yeah. Thank you, Neil. 1030. Thank you, Neil, for being a faithful watcher. And RG Jubilee, Dave Stangy, our #1 gold, diamond, and universe watcher there. Dave, thank you so much. Marty and I have been doing this 5 years, born out of the pandemic in March 2020. We are up to over 1,300 episodes, and none are more popular or more fun to do than with you, my friend. And thank you so
No
much.
problem. Yep.
Appreciate that. And if you got a suggestion of a topic for Terry, put it in there. We won't turn it off right away, or email me at marq@americanspacemuseum.org. So tomorrow we'll look at some pretty pictures, look at the weekend celebrities that Marty and I ran into at 2 events going on here to Orlando, and do, of course, a couple of shuttles of the month of June, and look forward to TGIF, quite frankly, on my end of it, as we continue to do a lot of good things in this museum to make the experience even better for everybody, and that includes a space store that we are going to build inside the museum, and thanks to Mitch Rothman helping us raise money for that, and you all. Charity auction is Saturday. All right, hit that QR code, register. We'll ship you anywhere in the world there, Ad Kahara. Okay, whatever it costs, you're going to pay, but we do ship worldwide on there for artifacts you buy. But download the app that it's on, and you'll enjoy a lot of space history just doing your dishes, house cleaning, whatever during Saturday. So until tomorrow, thanking Marty Winkle for a good job on the Streamlabs there, and my friend Terry White for his insight into the Space Shuttle era. I'm Mark Marquette saying we can't wait to see you in our museum to bridge the space between us.